Hello everyone, in this tutorial we'll be creating a snake game. So as we can see, apples appear on our playing grid, and when the snake eats them, the tile size increases and our score goes up. Without further ado, let's get started. Firstly, after opening our project in Visual Studio, let's create a new class. So let's go to View, Solution Explorer, then go to Snake, right click, go to Add, then go to New Item, and we will name this class Chord. This class will contain two integer fields, an x and a y component, so let's create a private integer called x and a private integer called y. We'll then create some properties for these, so type prop for the shortcut, double tab, and we will call this capital X, and in get instead we will put return lowercase x, and then we can duplicate this and replace the x with y and replace the name with an uppercase Y. Finally, let's create a constructor. So using the ctool snippet, we can add to the parameters an integer called x and an integer called y, and then we will set this .x equals x and this .y equal to y. We'll expand on this class later, but for now let's move back over to program. So let's start off by defining the width and the height of our playing area. So let's create a coordinate called grid dimensions, and we'll set it to a new chord, and for my case I'll use 50 and 20, but feel free to use any area you would like. Then let's create a starting position for our snake. So we have another chord, this time we'll call it snake pause, set it to a new chord, and we will set it to 10 along the x and 0 along the y. Now let's work on displaying our playing field. So to do this, let's start by creating a for loop. So we'll go for, and instead of I, we'll replace this with y. So whilst y is less than grid dimensions dot y, so the y value of our grid, and then we'll create another for loop in here, and it will be integer called x, which will also loop until grid dimensions dot x. And then we can now focus on printing the walls of our playing area. So we want to print out our walls if the current x value is 0 or current y value is 0. So this will print the left side of the grid, this will print the top side of the grid, or x is equal to grid dimensions dot x minus 1, so this will print the right side of the grid, or y is equal to grid dimensions dot y minus 1. And if this is the case, we will use a console.write statement. Note that this is write, not write line. And for now, I'll print out a hash symbol to represent the walls, and otherwise we'll just want to print out an empty space to represent an empty space in the grid. After our inner for loop, we'll add a console.writeLine to print a line in between each row. So now when we test our program, we will see a grid printed out. So great, that's our playing field printed out. Next, let's work out how to print the head of our snake. To make it easier for ourselves, let's create a chord object in our inner for loop, which will correspond to the current coordinate being looked at, and we will set it to a new coordinate of x and y values, with the x value being this inner loop value and the y value being the outer loop value. Then let's come to our if statement here, and we will do if snake pos is equal to current chord, then let's print out a symbol representing the snake's head. So I will use this square ASCII character, which I'll leave in the description for you below if you want to use it too. And then we'll also want to change the if statement here to an else if instead. Then after running our code, we'll see that our snake is absolutely nowhere to be found on our grid. This is because we are using the equal operator on our custom class, which ends up comparing the references of the variables themselves and not the attributes of the class. So to fix this, let's head it back over to our coordinate class, and we will create a new method called a public. It will override equals. So here it takes an object called obj, and it will return the base for now, but we don't want that. So firstly, we want to check if our object is equal to null, or the type of the current object, not obj, but the object that equals is being called on, is equals to the type of our object, and we want to apply a not here. So we're either checking if the object provided here is null, or the types of the current class and the object class do not match. And if that's the case, we can just immediately return false, because that's not what we're looking for. Then at this point, we know that object is of type chord, so let's cast it. So we can create a chord called other and cast it to a chord, and then we can return if the x from this class is equal to the other.x, and if the y from this class is equal to the other.y. So let's go back over to our program class, and instead of using the equal symbol here, let's do dot equals, and we will place our current chord object in the equals. So now when we play, we can see that our snake is printed, but it's actually printed on top of our grid, which isn't great. So all we have to do is change the y component here to 1 for the snake position. Then when we play again, we can see our snake is printed out on the playing grid. Now let's focus on placing the apple on the playing field. So back at the top of our program, we will create a random called rand, which will create the random positions for our apple, and then we will create a coordinate called apple pos, which will be set to a new chord with its x value being rand dot next, and then we want our value to be in between 1 and the grid dimensions along the x-axis -1. So here we will get an x-axis within the playing field, and it won't be on top of the grid or outside of the grid. And then we'll want to do the same again for our y value. So we want to do 1 grid dimensions dot y -1. Then below where we place our snake on a grid, we can create another else if statement, and here we will compare whether the apple position is equals to our current coordinate, and if it is, then we'll use console.write, and again you can choose any character you want, but for now I will just choose an A to represent the apple. Then when we play the game, we can see that our apple is placed here, and every time we start up our game it will be placed in a random position. With that out of the way, we've now gotten to the point where we can focus on making our snake move. So firstly, we want to decide on the delay between each frame of our game being rendered. This will vary based on your preferences, but I'll choose 100 milliseconds per frame. So underneath our apple position, we can create a new integer and name it frame delay milli, and I'll choose 100. Next, let's start on working on our game logic. So let's create a while loop which will loop true, and then place all of our current code with the for loops inside of this while loop. Then at the beginning of a while loop, we will add a console.clear, so that will clear the previous output on the console at the beginning of each frame. And at the end, we'll want to add a thread.sleep frame delay milli, which will make the program wait for the amount of specified milliseconds and then render the next frame. So let's try this, and we can notice our playing field being rendered every 100 milliseconds. So now to make use of the frames, we can work on the snake movement. So we'll need a way to represent the different directions that the snake can head in, which will either be up, down, left or right. So there are several ways to do this. For example, you could use integers from 1 to 4, but for this tutorial we'll use an enum named direction. So let's come back over to the Solution Explorer, right click, go to add new item, and we will name this direction. We'll add it, and instead of the class here, we'll change this to an enum. We will create up, down, left, and then right. So that's pretty much it for the direction enum. So let's go back over to our program, and we'll come back up to the top, and we will create a new direction, and we'll name it movement direction. And for the start of our game, we'll set it to direction.down. Then we can head back over to our coordinate class and create a method which will change the x or y value based on the direction passed into it. So to do this, let's create a public void and call it apply movement direction, and it will take a direction called direction. All we have to do is use a switch on our direction. In the case that our direction is left, then we will decrement our x value and break. In the case that our direction is right, then we will increment our x value and break. In the case that our direction is up, then we will decrement the y value and break. And finally, in the case our direction is down, then we will increase the y value and break again. And that's our chord class finished up. Let's head back over to program. Then under our console.clear statement, we can apply the movement. So we can do snake pause dot apply movement direction and pass in our movement direction enum. Then let's give this a test. And then we can see that every frame our snake is moving downwards. But of course, we also want to be able to control the direction our snake moves in. So depending on which key the user presses, the snake should move in the corresponding direction. So to do this, we'll need to replace this thread.sleep. The problem with thread.sleep is that it puts the thread running the game asleep, and with that, there is no way to detect whether any keys are being pressed and which key is being pressed. So to replace that, we'll have a while loop, which will keep looping until the amount of specified milliseconds, and during for that, we can continuously check for input, and then change our movement direction corresponding to which key has been pressed. So we'll delete this, and we will create a date time. Name it time and set it to date time now. Then we'll create our while loop. So we'll create another date time, and it will be datetime.now minus the time, and we will choose the milliseconds. And if it is less than our frame delay milliseconds, we'll want to check for input. So we will do if console.keyAvailable. So this will either return true or false depending on whether a key press is available in the input stream. And if there is a key available, we'll want to check which key it is. So let's do console key, name it key, and we will read the key from the console. So console.read key, and we will convert this to the key pressed. So like before, we will just use a switch statement to compare which key is being pressed. So in the case that we are pressing console.key, the left arrow, feel free to change this to WASD if you want as well. Then we will change our movement direction to our left direction, and we will break. Then do the same for the other directions. So now when we give our program a test, we can see the snake now moves in any direction we press. So press down, press left, press right, press up, and the snake now moves around the grid in the direction we want it to. A striking difference between our game and the snake game is that our snake only has a head and has no tail at all. So let's head back up to the top of our program once again, and to record the positions of the snake's tail, we'll want to create a list of type coordinate, and we will call this snake position history, and we'll initialize it to a new list. Then beneath it we will create an integer called tail length, and we'll set it to 1 for now, and every time the snake picks up an apple, tail length will be incremented so that the snake grows a longer tail. Then let's come back down to the bottom of our program. So beneath our for loop and above our datetime.now, we will add to the snake position history a new coordinate containing the snake's positions x and its y position. Here we must create a new coordinate, as our list actually uses references and not values when we add it to a list. So as opposed to this, if we just used our snake position here, then every time we change our snake position, this will also be reflected in history, which is not what we want. We just want the x and y values of the positions it was at, and for it not to be updated every time the snake moves. And then to make sure our tail isn't longer than it needs to be, we will use if snake pos history dot count is greater than our tail length, then we will do snake pos history dot remove at 0, meaning it will remove from the front of the list, so we append new entries at the end, and the oldest, which will be at the front, will be removed. And now we can render the tail to the screen, so we can head up here, and where it says if snake pos equals to the current chord, we can also do an or and do or snake pos history dot contains current chord, and if this is the case, we'll also want a square to be printed. So this part here will print the head of a snake, and this part here will print the tails based on the previous snake positions. And so let's give this a test, and we can see our snake has a little tail every time it moves. So now let's focus on picking up the apple. So after our for loops, we can create an if statement which will check if our snake position is dot equals to the apple position, and if this is the case, then we want to increment our tail length to allow the tail to be 1 longer, and we want to randomize our apple position again. So you'll do new chord random dot next 1 grid dimensions dot x minus 1 and rand dot next 1 grid positions dot y minus 1. And then when we run our program again, let's try and pick up some apples this time. We can see that every time we pick up our apple, our snake tail grows by 1. Okay, so now that we've got that done with, let's work on creating a score. So back up to the top as usual, we will create a new int score and set it to 0. And then under our console.clear here, let's just focus on using a console.writeLine and printing out the score to the console. So we will do score, then plus score. So if we run it again, we'll just see at the top of every frame we have the score value printed. And then every time we get an apple, so here we'll increase the tail length, let's also increase the score by 1. So last of all, we'll want to check for game over conditions. The game over conditions being if a snake head has collided with any walls, or if a snake has collided with its own tail. And if this happens, then we'll want to reset the game back to its initial state. Underneath this if statement here, you'll create an else if, which will check if our snake position .x is equal to 0, meaning would be on top of the left wall. If our snake position .y is equal to 0, meaning we'd be on top of the north wall. Then if our snake position .x is equal to the grid dimensions .x minus 1, and if our snake position .y is equal to grid dimensions .y minus 1. And if this is the case, then we'll want to reset our score back to 0, put our tail length back to 1, put our snake back at the original position, so we'll change this to a new chord which will be 10 and 1, clear our snake history list which contains all of the tail positions, and we'll want to reset the movement direction to direction .down. Then finally we'll have to add a continue statement on the end of this. So this continue here will skip straight to the next frame and it will not add any new positions to the snake's tail history. And finally, one condition I've actually forgot to add for a game over condition is if the snake head collides with its own tail. So you will do snake.pos history.contains our current snake position. So that should be all the code we need for the game. Let's give it a try. So it gets an apple, the score went to 1, 2, 3, 4, so let's just try colliding with wall, and you can see our score went back to 0 and our snake started from its position and went downward. Let's collect some more apples. And this time I'm going to try colliding with the snake's own tail. So I'll go up then down, and you see the game resetted, and that is a snake game finished. And that is all of our code finished. Down below I have a link to the blog post which contains step-by-step instructions in a text form about how to create this game, and there will also be a link to the GitHub repository which will contain the full code. As always, thank you for watching this tutorial, and I'll see you in the next.